Lesson 17, Angle Relationships and Congruent Triangles. Your objectives for this lesson are to find the measure of interior and exterior angles of triangles, apply theorems about the interior and exterior angles of triangles, use properties of congruent triangles, and prove triangles are congruent by using the definition of congruence. So let's get started. The vocabulary for your lesson are auxiliary line, corollary, interior, exterior, interior angle, exterior angle, remote interior angle, corresponding angles, corresponding sides, congruent polygons, and let's start with the definition of auxiliary line. This is a line that is added to a figure to aid in a proof. For example, we have line L that we have drawn, and this is used in the Triangle Sum Theorem. This way we have two exterior angles, 4 and 5, that we can work with in order to find values. The Triangle Sum Theorem, it says that the angle measures of a triangle, the sum, is 180 degrees. So the measure of angle A plus measure of angle B and measure of angle C added together is always 180 degrees. If you take a sheet of paper and you draw a triangle of any sort, and you just cut out the angles of your triangle and put them together, you'll find that it makes a straight line every time, no matter what kind of triangle you draw. It makes a straight line. Let's look at an example. After an accident, the positions of cars are measured by law enforcement to investigate the collision. Let's use this diagram drawn from the information collected to find the measure of angle XYZ. XYZ will be this top part minus the 12 degrees. So, first of all, we know that the measure of XYZ and the measure of YZX and the measure of ZXY equals 180 degrees. This is from the Triangle Sum Theorem. The three angles in a triangle will measure 180 degrees total. Then we can substitute in for 40 for angle YZX and 62 for ZXY. We can simplify, and then subtracting the 102 degrees from both sides, we get that the measure of XYZ is 78 degrees. Let's look at another example. This is the same diagram, but this time we want to find YWZ. So YWZ. This will be the entire angle associated with the vertex W. We know that the small angle at the top is 12 degrees. We don't know what angle X is, and we need to find X in order to find W. So step 1, let's find WXY right here. We know that the measure of YXZ and WXY will equal 180 degrees because of the linear pair theorem and angle addition postulate. We know that those two angles make a straight line. Then we can substitute in 62 degrees for angle YXZ, and we add that to WXY. That's still 180. In order to solve, all we need to do is subtract 62 from both sides, and we get that the measure of WXY is 118 degrees. So this is step one. Now we found the measure of two of the angles of the triangle. Step two, we want to find the measure of YWZ. We know that the three angles in the triangle add up to 180 degrees, and this is from the Triangle Sum Theorem. We can substitute in 118 degrees for WXY and 12 degrees for XYW. The only one left is the one we were looking for. We simplify, subtract 130 from both sides, and we get that the measure of YWX is 50 degrees. Corollaries. A corollary is a theorem whose proof follows directly from another theorem. Here are two corollaries to the Triangle Sum Theorem. Remember, that theorem says that if we add up the three angles in a triangle, we always get 180 degrees. So, Corollary 422 states that the acute angles of a right triangle are complementary. This would make sense because if a triangle has 180 degrees and we subtract 90 from it, what's left is 90 degrees. Therefore, the other two angles must be complementary. And 423 states that the measure of each angle of an equal angular triangle is 60 degrees. And this comes from saying if all of the angles measure 180 and they're the same, we simply divide 180 divided by 3 and get 60 degrees. So an equiangular triangle has 60 degree angles, always. Let's look at an example. One of the acute angles in a right triangle measures 2x degrees. What is the measure of the other acute angle? Well, let's let the acute angles be A and B, and the measurement of A is 2x degrees. So the measurement of A plus measurement of B is 90 degrees. Acute angles of right triangles are complementary. This is from the corollary we just heard. 2x plus the measurement of B is 90 degrees. This is substituting in 2x for the measure of A. And the measure of B is 90 minus 2x degrees. Subtract 2x from both sides. The interior is the set of all points inside the figure. The exterior is the set of all points outside the figure. Seeing how figures that we use, polygons, are closed, just think of inside the house or outside of the house. Looking at our figure, an interior angle is formed by two sides of a triangle. An exterior angle is formed by one side of the triangle and extension of an adjacent side. So we've extended this side of our triangle into a ray, and this creates the exterior angle. Angle 4 is an exterior angle. Angle 3 is an interior angle. Each exterior angle has two remote interior angles. A remote interior angle is an interior angle that is not adjacent to the exterior angle. Looking at our picture, angle 4 is our exterior angle. The remote interior angles will be 1 and 2. Angle 3 is an interior angle. Angle 4 is exterior. the remote interior angles of angle 4 are 1 and 2. They are not next door neighbors. The exterior angle theorem is used to find the measures of interior angles and prove congruence in triangles. And it states the measure of an exterior angle of a triangle is equal to the sum of the measures of its remote interior angles. So in this case, the measure of angle 4 is equal to the measure of angle 1 plus the measure of angle 2. For example, if we want to find the measure of angle B, first of all, we know that angle A plus the measure of angle B equals the measure of angle BCD, the exterior angle of the triangle. So we can plug in the values, 15 for measure of angle A, 2x plus 3 for the measure of angle B, and 5x minus 60 for the measure of angle BCD. We'll simplify that up a bit, and we get 2x plus 18 equals 5x minus 60. Subtracting 2x from both sides and add 60 to both sides, we get that 3x is 78. And then we divide by 3 to get that x is 26. So all we need to do now is plug in 26 into the formula for angle B. Measure of angle B is 2x plus 3, so that's equal to 2 times 26 plus 3, which is 55 degrees. The third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, then the third pair of angles are congruent. This only makes sense because all three add up to 180. And this is kind of like being supplementary to something. The measures of the other two are supplementary to the third. If you can prove two angles are congruent, then you can prove that the other ones are as well. For example, find the measure of angle K and the measure of angle J. We know that K is congruent to J because of the third angles theorem. That means that their measures are equal, and that's by definition of congruent angles. So then we can plug in what we know. 4y squared equals 6y squared minus 40. And all we're doing is substituting in the values we were given for the measure of angle K and for the measure of angle J. We can simplify. Subtracting 6y squared from both sides, we get 2y squared equals negative 40. Y squared equals 20. All we did was divide both sides by negative 2. So the measure of angle K equals 4y squared plus 4y squared, which is 4 times 20, and that's 80 degrees. In this case, you might be tempted to take the square root of both sides to solve for y, but since we're using y squared in our formula, you want to just leave it as it is. Since the measure of angle J equals the measure of angle K, then the measure of angle J is also 80 degrees. Geometric figures are congruent if they are the same size and shape. Corresponding angles and corresponding sides are in the same position in polygons with an equal number of sides. This is kind of like when we talked about corresponding angles when we had two lines cut by a transversal. They are in the same position within the figure. kind of like desks in the room and who sits there. Two polygons are congruent polygons if and only if their corresponding sides are congruent. Thus, triangles that are the same size and shape are congruent. The properties of congruent polygons. Using a diagram, we see that if the sides are equal, if the angles are equal, then they are congruent. Same with a rectangle or a triangle or any polygon. The corresponding angles are congruent and the corresponding sides are congruent. To name a polygon, write the vertices in consecutive order. For example, you can name polygon PQRS as QRSP or SRQP, but not as PRQS. In a congruent statement, the order of the vertices indicates the corresponding parts. When you write a statement such as triangle ABC is congruent to triangle DEF, you are also stating which parts are congruent. For example, given that triangle PQR is congruent to STW, identify all pairs of corresponding congruent parts. The angles. Angle P is congruent to angle S. They are listed first. They are the ones that would be corresponding. The middle two angles would be congruent, Q and T, because they are listed in that order. And then R and W would be congruent. The sides, PQ and ST, the first two, QR and TW, and then PR and SW. If you have doubts, it's easiest to draw triangles and label them in the order you're given. Then you don't miss any of the side segments. Given that ABC is congruent to triangle DBC, find the value of X. Well, first of all, we look and we see that BCA and BCD are right angles. So BCA and BCD, they form a straight line, AD. If one of them is a right angle, the other must be, because they are supplementary. This is perpendicular lines. So BCA is congruent to BCD. That's the right angles congruency theorem. So the measures of BCA and BCD must be the same, and that's just by definition of congruent angles. So we can then state that 2x minus 16 degrees equals 90 by substituting values in for BCA and BCD. If we add 16 to both sides, we get that 2x equals 106. So all we would have to do is divide by 2, and x is 53. This was what we set out to find, and we have found it. Given that triangle ABC is congruent to DBC, find the measure of angle DBC. Well, we know that the measure of ABC and the measure of BCA plus the measure of A equals 180 degrees from the Triangle Sum Theorem. The measure of ABC plus 90 plus 49.3 equals 180. And all we've done here is substitute the values for the measure of angle BCA and measure of angle A. That means that the measure of ABC plus 139.3 is 180 degrees by simplification. We added the two numbers together. Then if we subtract the 139.3 from both sides, we get that the measure of angle ABC is 40.7. We know that angle DBC is congruent to ABC because of the corresponding angles, of course, of congruent triangles are congruent. That means that their measures are the same by definition, and the measure of angle DBC is 40.7 degrees by the transitive property of equality. Let's look at another example. We are given angle YWX and YWZ are right angles. We also are told that YW bisects angle XYZ. W is the midpoint of XZ, and XY is congruent to YZ. We want to prove that triangle XYW is congruent to triangle ZYW. So first of all, we're going to talk about our right angles because those are given. We have two angles given. And the congruence, that means that those angles are congruent because right angles are congruent to each other. YW bisects XYZ, that's given. And we are given that angle XYW is congruent to ZYW, and that's the definition of a bisector. It cuts an angle in half. W is the midpoint of XZ, and that's given. XW is congruent to ZW, that's the definition of a midpoint. And YW is congruent to YW, that's the reflexive property of congruence. And we have angle X is congruent to angle Z, that's the third angles theorem. And that gives us that XY is congruent to YZ, that is given. And thus, the two triangles are congruent by definition of congruent triangles. If we prove that all corresponding angles and all corresponding sides are congruent, then we've also proven that the triangles are congruent. The diagonal bars across a gate give it support. Since the angle measures and lengths of the corresponding sides are the same, the triangles are congruent. Here's our picture. If we are given PR and QT bisect each other, an angle PQS is congruent to angle RTS, and QP is congruent to RT, we want to prove that triangle QPS is congruent to triangle TRS. So, first we'll say QP is congruent to RT. That's given. Angle PQS is congruent to RTS. That's also given. PR and QT bisect each other. Given again. And we say QS is congruent to TS and PS is congruent to RS by definition of bisector. Angle QSP is congruent to TSR, vertical angles theorem. Angle QSP is congruent to TRS. That's by the third angles theorem. And thus, the two triangles are congruent by definition of congruent triangles. Now you try. Here's another one. For next class, I want you to complete the you try exercises We'll check your answers in class. Bring your notes to class to use in problem solving.